Hi everyone, my name is GREYTEST. On this video I'm going to be showing you how to design your column. Okay, now if you've been following, we have designed our beams, we've designed our slab, now distributed the load to the beams. Now we are going to distribute from beam now to down to the column. Okay, you can check out those other videos from my YouTube channel, which I'm going to drop the link below the description of in the description of this video. Okay, if you like what you're seeing already, why not give it a thumbs up, subscribe to my YouTube channel, click on the bell icon. Okay, the subscription is free. Click on the bell icon and you'll get a notification whenever I post a video. I usually post videos on designs on a weekly basis, so as to encourage people that are coming up. Okay, if that is correct, now on this particular GA, I'm going to design this particular column that is here, which is this. The reason is because this column, I feel, is the most critical of them all. Okay, so I'm only going to design this column on this video. Okay, now to begin, this column, if you can see, look at, is carrying this beam 3. Look at this one and this one. Okay, and it's also carrying this beam. Now it's not carrying the entire beam, it's not carrying the entire beam here, it's not carrying the entire beam here. Now it's carrying half of this here, carrying half of this beam here. Okay, the column here is actually carrying half here and half here. Now it's carrying half of this beam. As you can see, there is a column here. Okay, now what is the span from here to here is 3115. So if you take half of this length, it's going to give you 1.56. I stand to be corrected. Okay, if you take half of this, it gives you 1.915 on both sides. Okay, now if you sum these two values, 1, 2, it gives you 3.83. okay, that means the length is 3.83 and then the breadth is 1.56. okay, now to get the particular area that this particular column covers, at which the load, okay, that it covers. Now loading, the basic loading parameters. Now let's go into it. Now look at the area of the slab supported. Okay, the area of slab that this particular column carries is 3.83 times 1.56, which will give you 5.97. now the wall / beam length supported. Okay, this is the beam, this is the whole length. Okay, and this is another length. Now if you sum 3.83 plus 1.56, okay, to give you 5.39. now the roof load, this roof load has to do with both the dead load and the live load. Okay, and when you are dealing with your roof load, that's on the dead load, we are talking about the felt, okay, and then the screeding, okay. The felt and then the screed, sorry, okay. Then when you want to then that of the life load of that roof is actually 0.25. Now when you sum that 2 plus 0.25, it actually gives you 2.25. okay. I will still take you back to your your reinforced concrete design books, okay. You can get it, the one by Victor Oyenuga, RCD, okay, reinforced concrete design book by Victor O. Oyenuga, okay. Down below the description of this video, I'm going to give you a link, okay, my social media platform. You can chat me up, okay, and then I'll guide you on how to actually get this material from, okay. But if you are outside Nigeria, you can get Mosley and Bongi, okay. Now the first to roof level, which is roof beam load, okay. Now this is it, multiplied by 5.39, which is this 5.39, which is the wall slash beam length, okay. The roofing, which is 5.97 times 2.25, okay. That's the area multiplied by the life and dead load of the roof, okay. That's the area of the roof, the area it covers. This is the area that covers, now that is carried by this column, okay. Then the column own load and finishes, okay. Let's say it's 11 kilonewton. Now I don't want to go into details of everything. Now the column own load and finishes, there is a way you do that calculation, which is a very simple one, okay. You just know the particular area of that particular beam, you multiply by the density of concrete, multiply by the factor of safety, that's the dead load, okay. I don't want to go into details. Now when you sum this value plus this value plus this, it gives you 50.61. That's the column from first to the roof is actually 50.61. Now from the ground to the first floor, we'll take the load from above, yes, which is, the column from the first to the roof is actually going to be added to that of the ground, because the column down is actually carrying the column up. Now if that is correct, we'll take that load and transfer it, okay. Then the wall slash beam, okay, which is 17.5 is actually gotten from a simple calculation like this, which is a factored beam slash wall load, okay. Now this is simple calculation, okay. The own load, okay, finishes wall, okay, factored beam slash wall load, okay. I believe you understand what is going on here, okay. Come back to this 17.5 multiplied by the wall slash beam length, which is 5.39. Then slab load is actually gotten from the slab load itself, okay. Now you multiply by the area that it covers. The area it covers is 5.9. Now this is the particular area, the whole area covered carried by this particular column. Okay, don't get it twisted, please. Okay, then column own load and finishes for ground floor. Okay, let's see, it's 15 kilonewton. Now if that is correct, column, you drag, you drop. Okay, T, enter, F, enter. Output name, column 001. Okay, password, no password. Job reference, engineer J. March 2020, 2410. Total number of columns. Okay, we are going to design 2 columns. Maximum steel. Okay, maximum number of steel that I want to use is 4. Your D over H is actually gotten from a simple calculation, which is this. Okay, D equals to H minus concrete cover minus diameter divided by 2. You do that, you get this value. Okay, 0.86. Enter. Now column 1. Okay, let's see first. Okay, the column we want to design is actually a uni-axially loaded column. Okay, it is uni-axially loaded column. Now this is a biaxially loaded column. Okay, you can visit you can get RCD, Reinforced Concrete Design book by Victor Yenuga, so as for you to understand better what an axially loaded column is, uni-axially loaded column is, and biaxially loaded column. Okay, biaxially loaded are always mostly corner columns. Okay, columns by the corner, they are biaxially loaded. This is uni-axially loaded. You can see it's carrying 3 different members. Okay, so it is 2. Now the shape of the column is actually a square column. So 1, you can see it's very interactive. Okay, the column is actually braced. It is braced because it is laterally supported by wall. Okay, it is laterally supported by a wall, or when it is supported by buttressing. Okay, we said that column is actually braced, so it's a braced column. Now BXBY, this is actually gotten from a chart. It's gotten from a chart. Okay, now down below the description of this box, I'm going to drop my WhatsApp contact, and you can follow me on any of those social media platforms. Okay, where you can as well get this chart from. Okay, so using that chart is very simple. Okay, this is just the chart. This is just the chart. This is the chart. Okay, this is the chart. Okay, enter column dimension. This is 230 by 230. What is the length? It is 3.50. Now what is the load? Now, as you can remember, this is the first load for first to roof, 50.61. Now, what is the moment? Now, the moment is actually gotten from the beam design. Okay, now if you, as you can see here, what is the column that is the beam? The beam here is beam 3. Look at the beam here now is beam 6. If you can remember, we didn't design our beam 6. I'm sorry about that. Okay, I am trying to make this video as brief as possible, but let me just briefly explain something. Now, this beam, this moment is actually gotten from that beam design. As you can see from this your beam, you have moment. Okay, now the moment is actually transferred. You take that particular moment you get from your beam and then take it here for your design. But since we don't have beam 6, okay, I'm only going to assume 0 moment. Okay, because there are cases where you have 0 moment. So for column 2, now we said this is now what do we do? This is now okay to first. Okay, the column is a uniaxially loaded column. Okay, the column is what? Square column. Is the column braced? Yes. Okay. Please, I'm going to advise you to actually study this chart. Okay, this is just the chart. This is just the chart. Okay, so I can send you a soft copy. You can just DM me on any of the social media platform, or you send me a message on WhatsApp. You can actually get this soft copy, okay, of this. This is just the chart. So just sit down well and you'll be able to interpret this better. Okay, the dimension is, the length is 3000. What is the load? This is the load we got from our calculation, 222.74. Now the moment, like I explained earlier on, is actually gotten from your beam, the beam calculation you have done before. Okay, the beam calculation you did before. So 0, 0. Now, any column to be designed? No. Now you can close it, as designed it already. So you just come back to your RCD 2000. You have your column which we just designed. Not bad. You open, check your results. Okay, and that is all. If you have enjoyed all that you have been seeing, why not give it a thumbs up? Okay, subscribe to this channel. It's free. Just click on that red button, subscribe. Click on it, it's free. Okay, click on the bell icon. You get a notification whenever I post a video. I post videos on designs on a daily basis, sometimes on a weekly basis. Okay, so as to help people who want to really understand how to design. We use design. I have designed both the slab and the beam. As you can see, we've been transferring the load from the slab down to the beam down to the column. Now our next video is going to be on base design. Okay, how you can design your base from the column coming from from the load coming from the column. Okay, that is that. And again, if you have a design which you want to kind of bring us in, we can come into a situation where you want us to design for you. We can design for you. We can supervise your site. If you have a supervision job, we can come and supervise. Okay, we can design at an affordable rate. Okay, thank you.